Molecular autopsy, the final investigation. Okay, so today we're going to step into the world of forensic science to unravel a truly modern medical mystery. What happens when the cause of death is completely invisible? Just imagine the unthinkable. Someone, often young, seemingly healthy, just dies. Suddenly, no warning, no obvious cause. It's an absolute tragedy that leaves behind this devastating question mark. So, for both the investigators and, of course, the families, this is just the most baffling scenario you can imagine. The standard examination, the autopsy, it offers zero answers. It just leaves this void where a cause of death should be. So what do you do? Where do you even turn next?
All right, let's dive into what the forensic experts call a negative autopsy. And believe me, it happens way more often than you might think.
Get this, it's around 30%. That means nearly a third of all sudden cardiac deaths in young people, we're talking under 35, are left completely unexplained after a standard autopsy. This isn't some rare fluke, it's a massive gap in our understanding. And that is the whole idea behind a negative autopsy. It means the physical stuff, the organs, the tissues, all of it, they look perfectly normal. So it points investigators towards, a ghost in the machine, a fatal glitch in how the body functions, not in how it's actually built.
So, to find that ghost, investigators have to go deeper. I mean, way deeper. They have to move past the microscopic level, all the way down to the molecular. They literally have to search the blueprint of life itself.
And that's where our key tool comes in, the molecular autopsy. So what is it? It's basically a genetic investigation, done post-mortem, specifically to hunt for these hidden inherited conditions that can make a heart just stop, all without leaving a single physical trace.
Okay, here's a really great way to think about it. Imagine a normal autopsy is like a technician opening up your computer, right? They're looking for the obvious stuff, a fried motherboard, a broken hard drive, physical damage. But what if the computer crashed because of a single line of bad code? The hardware would look totally fine, right? And that right there is exactly what a molecular autopsy does. It's checking the software, the DNA, to find that one fatal bug that caused the whole system to shut down.
So, what are these fatal bugs we're talking about? Well, forensic scientists are on the hunt for a very specific category of genetic culprits.
They're called inherited arrhythmogenic syndromes. Yeah, I know, it's a mouthful. But all it really means is genetic conditions that can cause a super dangerous, irregular heartbeat, what doctors call an arrhythmia.
And these syndromes pretty much fall into two main buckets. You can think of them as electrical faults. Those are the channelopathies, basically problems with the heart's wiring. And then you have these structural faults, or cardiomyopathies, which are issues with the heart muscle itself. The key thing to get here is just the difference between these two kinds of invisible killers.
Yeah, and this table really breaks it down for us. With the electrical faults, the channelopathies, the heart looks totally normal at autopsy. Why? Because the problem is in these tiny, invisible ion channels that control the heart's rhythm. But with the structural faults, the cardiomyopathies, they do cause physical changes to the heart muscle. The catch, in a young person, the disease might not have progressed enough to be visible to the naked eye. They call it a concealed cardiomyopathy. It's a silent killer that strikes before the physical evidence shows up. And what's really wild is that these conditions are often linked to specific, everyday triggers. For something called Brugada syndrome, death can happen literally during sleep. For others, like long QT syndrome or CPVT, it could be a sudden adrenaline rush from exercise or even just intense emotion. You can see how these details from the scene could become absolutely crucial clues for investigators.
But finding the genetic cause of death, it does so much more than just close a case file. It actually opens a door to prevention. It turns a tragedy into a lifeline. And this is the part that is so incredibly important. This is where the investigation becomes about prevention, because these conditions are inherited, right? So finding that genetic culprit in the person who died, it acts as a crucial, direct warning for their living family members, people who could be walking around with the exact same risk and have absolutely no idea. So this creates a really powerful path forward. It starts with a sudden, unexplained death. That leads to a negative autopsy. That, in turn, triggers the molecular autopsy. And if they find a dangerous gene, doctors can start something called cascade screening. That just means they start testing the close relatives for that one specific gene. And if they find it, those family members can get counseling and preventative care, which can and does save lives. And the urgency here is, it's immense.
For a lot of these genetic conditions, if you're a first-degree relative, a parent, a sibling, a child, you have a 50% chance, a coin flip, a 50-50 chance of carrying that same mutation. Suddenly, the molecular autopsy isn't just an investigation anymore, is it? It's a critical public health tool.
But it's not always that straightforward. Science rarely is, right? Reading the genetic code can sometimes raise just as many questions as it answers.
So investigators often run into something called a variant of unknown significance, or a VUS for short. What this means is they've found a little spelling difference in the DNA, but, and this is a big but, science doesn't yet know if it's just a harmless quirk or if it's the deadly bug they've been looking for. It's a finding that's stuck in this scientific gray area.
In dealing with that uncertainty, it takes a ton of careful judgment. This quote from the Society of Cardiovascular Pathology really sums it up. They say pathologists should record everything in the autopsy report, even a VUS that they just suspect might be the bad guy. Why? Because that piece of information could become critically important down the road.
And that's because this whole field is just moving at lightning speed. The recommendation now is to actually go back and reanalyze these uncertain variants every 5 years or so. Because what's a VUS today? Well, with new research, it could be reclassified as the definitive cause of death tomorrow. It's that fast.
Which really brings us to our final thought here. The molecular autopsy is this incredible tool that transforms a tragedy into a chance for prevention. It gives answers for the past and a real, tangible warning for the future. The challenge for us now as a society is to make sure this final, crucial step of the investigation is never, ever missed. So I'll leave you with this. If a clue to saving a life is hidden in the DNA of someone who has passed, how do we make absolutely sure it's always found?